Dear college math students, we're going to do two examples which involve angles of depression and elevation. It's important to note here that the mathematics that we're using is not new to us. We've been using this same mathematics in the previous examples. It's just that the context of the questions will be slightly different because they'll involve angles of depression and elevation. So just a couple of notes about angles of depression and elevation. For starters, they're measured from the horizontal. So if someone was up at the top of a cliff looking down at a boat, if you look horizontally, or if they were to look horizontally directly outward from the cliff, the angle they look down to the boat is the angle of depression. Now, if in fact you were down on the boat, looking back up to the top of the cliff, you look from the horizontal back up, and you would be looking up to the top of the cliff with an angle of elevation. Now those angles are equal to one another for this situation as well. So we'll utilise that fact in this example. So a lighthouse sits on the edge of a cliff. So this is our situation here. We've got a cliff with a lighthouse at the top of it, and this is 120 metres above sea level. So here is the sea down here along the bottom here. Just do a bit better job on that one. Okay, so this is the water down here. Here's the cliff, 120 metres high. So a person on the top of the cliff is looking down at a boat. So if they were to look through the horizontal here, I'll just try that again. So from the horizontal down to this boat, I'll just draw a little boat down here. The angle they look through to the boat from the horizontal is 55 degrees. Which means also that here we have 55 degrees. I think it's a little easier just to mark that angle in there and use this right angle triangle here to do this problem. Now the boat is, we want to know how far the boat is this distance from the cliff, from the base of the cliff. So from here to here, that's the distance we're trying to find. So with this diagram, you might have enough information now to pause the video and try this one yourself. Then I'll have a go at it. Okay, so for this one, we label the sides of the triangle as usual. We've got the opposite and we want the adjacent. So we're going to use tangent here. So the tangent, tan of 55 degrees is equal to the opposite, 120, over the adjacent, which is our d for distance. So that means the distance, whoopsie-daisy, our distance is equal to 120 divided by tan 55, which gives us 84 metres. About 84 metres. So the maths was not new there, but the way we drew the diagram was the new part. This one is really similar. You might want to pause the video and try and draw the diagram for this, then I'll have a go at it. Okay, so for this one, we've got a tower. So I'll just draw the tower here, just a line to represent that tower. And this man is 450 metres from the base of the tower. So 450 along here, making a right angle there. and he's looking up to the top of the tower through an angle of elevation of 35.6 degrees. Okay, so we want to know how high the tower is, h. In addition to this, the man, we're taking into account the fact that he is 150 centimetres or 1.5 metres tall. So in fact, we're not finding height at all here. What we'll do is, well, the total height of the tower is all of this plus this little extra bit for the man's height. We need to take that into account. But first, what we'll be finding is just the side length of this triangle. So we'll call this x for now. So we'll call that x. Right, so two sides we're using, we need to use tangent again. So the tangent of 35.6 is equal to the opposite x over the adjacent, 450, which means x equals, oops, I didn't write that properly, sorry. Put some brackets there. Okay, x equals 450 times the tangent of 35.6. Now, we need to add to this the man's height. So, total height of the tower is this amount here plus that 1.5 metres. So if we work this all out, we get a grand total of 323.7 metres. Okay, so as you go ahead and try some of these questions, remember the mathematics is exactly the same. It's just the way that the questions are framed, or the way they're built up with the diagrams using angles of elevation and depression. That's what will be different. So check out those questions in the description for the video and have a go with them.